Hello friends, today I'm going to show you something beautiful. I teach physics most of the time and I'm posting AP pre-calculus videos, but I also teach geometry. I have taught geometry and it's beautiful. I want to show you something. So how do we know that the three angles inside of a triangle add up to 180 degrees? We use it a lot. Where does it come from? How do we know it's really true? Well, here's how. Assuming that we're using Euclid's flat plane geometry, we can start with a couple of parallel lines and two transversals like we have here. The two lines are parallel, indicated by the little arrows. And the first thing that we notice, I've numbered these angles, that these angles here add to 180 degrees. So I can write this, that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Good with that. That makes sense, right? Those three angles, there's a line there, angle addition postulate. And because of what we know about parallel lines, I know that angle 1 and angle 4 are congruent to each other. And if they're congruent, then their angle measures are equal to each other. So the measure of angle 1 equals the measure of angle 4. Also, alternate interior angles, another pair of alternate interior angles, angle 3 and angle 5. Those are congruent to each other. And so the measure of angle 3 equals the measure of angle 5. Now, if I replace 5 here in this equation instead of the measure of angle 3, and if I replace the measure of angle 1 with the measure of angle 4 here, then what I end up with is this. And I'm just substituting because I know that these things are equal. That the measure of angle 4 plus the measure of angle 2, that one didn't get replaced, plus the measure of angle 5, which I replaced 3 with, equals 180 degrees. So I'm just substituting 5 and 4 for 1 and 3, and now I end up with this equation, and this tells me that the three interior angles of this triangle equal 180 degrees. That's the sum. And it doesn't matter what kind of triangle it is, right? It doesn't matter what the angles are that we put in there, right? And this is so beautiful. It's so simple. It's so simple. It's so precise. And assuming the postulates of Euclidean geometry, we know with 100% certainty, it can't be doubted, that the three interior angles of a triangle add up to 180 degrees. And so we traditionally write QED, proven. And it doesn't matter what the angles are. This could be an obtuse triangle. It could be a right triangle. We didn't specify any of these angles. This works for every single triangle, and we just proved it. And that's part of the beauty of geometry. So thanks for watching. Don't forget to like and subscribe.